In this video, I'll be walking through a quick demonstration of using the evaluation DEEPCRAFT Ready Models available for the PSOC 6 AI kit within ModusToolbox. I'll be using ModusToolbox version 3.4, which I already have open. From the quick panel, I'll select the New Application action from the Start section. This launches the ModusToolbox Project Creator application. On the initial screen, I'll expand the PSOC 6 BSB category and select the CY8C Kit-062S2-AI, which we see from the description is the PSOC 6.2 AI Evaluation Kit. Selecting Next will take us to the list of available code examples. From within the Machine Learning category, I'll locate and highlight the DEEPCRAFT Deploy Ready Model project. A high-level overview of the project is displayed with links into the source repo. Placing a check mark next to the project and clicking the Create button will then clone this project from the Infineon GitHub repository, along with any required middleware files and drivers. Finally, this step will create an Eclipse IDE project and automatically import that project into the Eclipse IDE. If you're working with VS Code or one of the other supported IDEs, please refer to the respective ModusToolbox users guides specific to that IDE for similar steps used to create the embedded project. When the project first opens in the Eclipse IDE, the README is displayed for the project. This README provides an overview of the project, highlighting the 6 available ready models that can be used, 5 based on using microphone or audio data, and the 6th being a gesture detection using the onboard radar sensor. There are other details within this README that we need to pay attention to. And one quick tip, the stock Eclipse Markdown Viewer does not do as well as a job with READMEs as, say, the internet browser. And clicking on View this README in GitHub will open the same README in a web browser that'll provide an easier to read format. The README does include specific steps for using the code example, including creating it in the supported IDE, which we've already done. And the section that we're looking for is the Operations section, where details regarding how to enable the different ready models are detailed. We see the 6 available ready models, along with the instructions to update the model selection variable that is located in the project's makefile. Let's return to the Eclipse IDE from ModusToolbox and open the makefile. Double-clicking will open in the code editor. And then to help you follow along, I'll right-click in the right margin and select Show Line Numbers. Continuing to scroll down, we'll get to line number 119. We see the default model selection is Siren. Let's keep that as is and compile our application using the Build Project action in the Quick panel. This initial build may take a few minutes depending on the speed of your computer, as this is a clean build. Once complete, we can use the Launch action to flash the image to our board, which I already have connected to the computer using a USB Type-C cable and the KitProg connector on the board. Once the programming completes, I can open up a serial terminal window to see the output of the project. Playing a Siren audio clip in the background, you can see that audio events are detected and a printf occurs. I want to point out where in the application code that the printf is, so that you can see which part of the application to modify as you leverage this evaluation ready model binary in your own project. Opening the audio.c file and scrolling down to the free RTOS audio task. We can see on line 272 the AI DQ function is being called, and that processes the AI model and returns a result. If the data out array value is a 1, then an audio event, in this case Siren, was detected. Then we see a simple printf and an LED being enabled. And this is the area code to focus on for adding your own functionality. The other audio models will behave similarly, so let's switch over to the radar-based gesture model to test it. I'll copy and paste the gesture_model value and ensure that I save the makefile. I'm going to select the program action directly, and this will kick off a build automatically. And after a few minutes, the build will complete, and flashing of the device will immediately occur afterwards. Returning back to our serial terminal, we can see the initial text is updated as we're using the gesture model. Refer to the README file in the browser view for animated images of the supported gesture motions. You can see in the terminal it is detecting several motions that I'm making with my hand. Similar to the audio use case, let's quickly go locate the section in the code where we can add our own functionality in response to these detected events. We'll start by opening the radar.c file and we need to locate the FreeRTOS processing task. Scrolling down, we find the start of this task on line 327. The AI detection function is actually happening here on line 356. And based on the result and a bit of debouncing, a printf and an LED control is currently implemented in this code. So this is the area to add your own functionality in response to gesture detection. Note that these ready models are time limited. They will function for, I believe, around an hour before timing out. More details on the production ready models are available at imagimob.com. Hopefully this video has been helpful in getting started with the DEEPCRAFT Ready Models and how to experiment with them in ModusToolbox. Thank you for watching.